I'm Chris, and in this calculus video, we're going to take a look at chain rule. So chain rule requires us to apply the same rules that we might have learned in power rule, except that there's going to be one extra step, and we're going to look at that one extra step in the context of this first example. F of x is equal to the quantity 3x squared plus 4 to the 5th power. So if we apply power rule to something like this and treat everything in parentheses as if it is just one term. So when you have something taken to a certain exponent, for power rule you multiply the coefficient times the exponent. So we'd have a 5 out front. And then you reduce the exponent by 1. So this would be then to the 4th power. So that's how we apply power rule to something like this. And now to complete chain rule, we just have this one extra step where we're going to, after we've done that part, multiply by the derivative of the inside. Multiply by the derivative of the inside. So the derivative of this expression, 3x squared plus 4, is just going to be 6x. The derivative of 3x squared is 6x by applying power rule. Multiply 2 times 3 and reduce the exponent by 1. So we get 6x to the first. And that's it for chain rule. And then what we have to do as our last step, even though this is mathematically correct for our answer, the way that you would see an answer choice written in maybe the back of your book if you're checking over your homework, or probably the way that your teacher would prefer to see it on a test, and certainly when it comes time for the AP exam, if you're in AP Calc, we want to go ahead and simplify by multiplying this times the coefficient, which would give us 30x times 3x squared plus 4 to the 4th. So that's our derivative of this first example using chain rule. Now let's try that same application on a slightly more challenging example in number 2. So here, for f prime of x, we're going to have 3 times 2x plus sine x to the 2nd. So for this first part, we get this the same way that we use power rule. We multiply the coefficient times 3, and then we reduce the exponent by 1, which gives us 3 times this entire quantity squared. Now we have to multiply by the derivative of the inside. So here, the derivative of 2x, when we apply power rule, we get 2. And the derivative of sine x, for your trig functions, that is something that you should memorize. If you haven't already gone through those, then you'll want to start memorizing those. Flashcards are a great way because it's something that will come up a lot. And here the derivative of sine is cosine. So we'll have 2 plus cosine of x. And similarly to what we did in number 1, we can then simplify this a little bit. Your teacher might prefer to see things written in different ways. But here you have 3 as your coefficient, and you can either leave this in its factored form, or you could distribute out the 3 to any of the expressions that you see here or FOIL it. For simplicity's sake, we're going to go ahead and leave this in factored form right now. So we'll have just 3 times our 2x plus sine x squared times 2 plus cosine of x. And we'll leave it that way, but just to show you an alternative that you might see or that your teacher might ask you to do on a test, a lot of times teachers will ask you to multiply the coefficient times whatever the derivative of the inside happened to be. So you could also see this written as, if you had distributed that 3 to each of those terms, 6 plus 3 cosine x times 2x plus sine x squared. And with most of the complex problems that you get to in calculus, whether it's chain rule, product rule, quotient rule, or even some of the more difficult power rule questions that you'll see, it's really important to understand algebraically what kinds of answers are equivalent so that we know how to manipulate questions in order to express them either in the form that the book would prefer to see it or in the form that our teachers would prefer to see it on an exam. For more, please visit our website, sandersondtestprep.com, and you can watch calculus and other videos at STP TV. Thanks for watching.